On example 7, find the value of x. Once again, we have ourselves a right triangle. We have the altitude drawn in from the right angle to the hypotenuse, but we have a different setup than we had before. So we're not even concerned about the length of that altitude. Instead, we have an unknown leg length, and we have the whole entire hypotenuse here is 12, and then a portion of that hypotenuse is 3. It's the smaller portion broken up by that altitude. Okay, so we'll go back to the drawing board over here, and let's see. Like we learned this new shortcut, right? It was the heartbeat method. Let's go ahead and apply the heartbeat method to it. So whenever we do, we're supposed to start on the hypotenuse, and it'd be 3 over I don't know, is equal to, I don't know, over the rest of this, which I guess is 9, because 9 plus 3 is equal to 12. Okay, but that would give us the length of this altitude here, which is not what we want. I mean, sure, we could probably find it and then use the Pythagorean theorem in order to find this x. That seems like too much work. All right. In other words, here is yet another example in which the heartbeat method does not work. So we'll go back to the original method. This is the foolproof method. It's just redrawing our triangles. Now, this time I'm not going to mess with the medium-sized one. I'm going to mess with, instead, the smaller right triangle here. Because look at the pieces that are drawn, or that were labeled on the small one. So on the small one, we get this 3. And the 3 is on the shorter leg. We also have the x. The x is on the hypotenuse, and that exactly matches up with the pieces that we have on the large one. So I'll redraw it, exaggerated with a short leg and a long leg. Right angle. So my 3 is on the shorter leg. I'll draw it right here. That's this 3. Right, and then my hypotenuse here is x. And now I have enough information to set up and solve for what x is equal to. So I'm going to start with, let's change colors here. 3 over x is equal to x over 12. Hey, do you recognize this kind of proportion? 3 over x is equal to x over 12. That looks pretty much like the definition of a geometric mean. All right, so let's do our cross multiplication, huh? So our first cross product there, x times x gives us an x squared, is equal to our other cross product, 3 times 12, pretty sure that's 36. Taking the square root, we get x is equal to 6. What we just found there is the length of our missing leg, and that missing leg, based on the proportion that we were able to solve, it's the geometric mean between 12 and 3. Why is that significant? It's the geometric mean between the length of the hypotenuse here and the shorter part of the hypotenuse that's closest to that x value, that leg length. Again, this sounds a little bit like a theorem. Why don't we go ahead and call this one the geometric mean theorem part 2, or the geometric mean leg theorem. So for your notes, the length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. Okay, so you can see I got 2 different versions over here, depending on whether we're talking about the shorter side, which is adjacent to this shorter piece, or the longer piece of the hypotenuse, which is adjacent to the longer leg, right? And I've got 2 different proportions set up over here in order to solve for that little x value, or this y value. All right, now I got a shortcut for this one too. It's not a heartbeat because we just saw the heartbeat doesn't work. And instead, this one's called a boomerang. So think of the shape of a boomerang, first of all. And I don't know if you've ever tried to throw a boomerang. I think you have to be like an aborigine from Australia to get these things to work properly. So you're supposed to throw it, of course, and it's supposed to come back to you. And I've never gotten one to come back to me. I don't know, I throw it. Maybe it starts coming back a little bit, and then, I don't know, it hits something or hits the ground or something like that. All right, so keep those things in mind. And when we throw this boomerang, we always throw it along the longest length, which, of course, is the hypotenuse. And we're going to start throwing it towards the other leg, the leg that we know or the leg that we're trying to find. So it looks like this. Okay, so two different versions of this boomerang method. So this first one is C over A is equal to, come back, A over X. And of course, it never goes all the way back to where it started, right? So you can see that kind of boomerang shape that's over there. Again, I started along the hypotenuse, and I throw it towards all the stuff I'm either looking for or have. So towards that other leg or towards that missing little segment piece, okay? So let's look down here at the bottom one. So this time, again, I'm going to throw it along the hypotenuse, but this time I'm going to throw it towards the right because that's where all the stuff is. So it'll be, in this case, C over B. Now it's going to start coming back towards us. B over Y, and it doesn't quite make it all the way. So close, so close. All right, so let's take a look at this boomerang shortcut method on that previous exercise that we just did, so we can see how this thing is set up. Let's see, what color have I not used? How about this lovely flavor of blue? It's a blueberry. Okay, so again, I'm going to throw it along the hypotenuse, and I'm going to throw it to the left. Why am I throwing it to the left? Because that's where all the numbers are. So 12 over x is equal to x over 3. I notice that's not exactly what we had before. 12 over x is equal to x over 3. Doesn't look identical to this one, but their cross products are definitely the same. I'd have x squared is equal to 3 times 12, 36, and it would solve for the exact same value. Okay, so now we basically have two little shortcut methods. We have a boomerang and we have a heartbeat. But, oh, wait a minute. Let's again go back to that 3, 4, 5 triangle, and let's see if we're able to apply it to this new one, this boomerang method. Okay, so let's see. I would throw it along the hypotenuse, and I don't know, I've got stuff in both directions. Let's just throw it to the left. I would have 5 over 3 is equal to 3 over this piece. I don't know how big that piece is. Okay, so maybe I throw it in the opposite direction. I would have 5 over 4 is equal to 4 over, I don't know how big that piece is either. Okay, so here is an example where neither one of those little shortcuts work. So when you're given all three sides of your triangle and you're looking for the length of that extra altitude that's right there, heartbeat's not going to work. And neither is the boomerang because you just don't have enough pieces in order to make that thing work. All right, so how do you solve it in this case? You solve it just like we solved it originally, which is just redraw the triangle so you can match up your pieces. So let's take a look at one more example before I leave you on your own to figure out a couple of these. So find the value of B, and we've got a right triangle, we've got an altitude thrown in here, and we want to be able to decide, is this thing heartbeat or is it a boomerang? So notice that we have the whole entire hypotenuse length here, and we have the leg length and a little piece of the hypotenuse. This looks like it's a boomerang. So let's come back over to example, what was that, number 8? Say hi, Rowan.
Hi.
No, you're supposed to say hi, Rowan.
Hi, Rowan.
There you go. All right. So I'm going to throw my boomerang. I'm going to throw the boomerang along the hypotenuse, and I'm going to throw it in which direction? I got to throw it towards the left because that's where all the stuff is. It's going to be 24 over 10 is equal to 10 over B. Write your proportion. 24 over 10 is equal to 10 over B. And now cross multiply. Solve your proportion. I'd get 24B is equal to 100. If you wanted to, you could have simplified your 24 over 10 And then divide, you get b is equal to 100 over 24. If you want to, you could throw that thing into the calculator. You could reduce that, and it reduces to 4.1666666, repeating and stuff. All right, there you go. Before I leave you, I would like for you to give 2 of these a try. All right, so find the value of the variable in each one of these cases. So you're not going to find the solution to each one of these in this particular video. I would like for you to try these on your own and then go to the next video where I work them out with you step by step.